So let's do an example with left-sided limits. So here's our problem. Here's our statement is, I want you to find the limit as x approaches 3 from the left, and that's what that little symbol means, of the function f of x. And our function f of x is a piecewise function. It looks like this. F of x is defined as x when x is less than 3. And f of x is defined as 0 when x is greater than 3. So graphically, what does that look like? Well, first of all, let's put some coordinates here. And it looks like 3 is an interesting point. When x is greater than 3, this function, we'll give it a green line, this function is just right along the 0. Okay. When it's less than 3, it follows the line y equals x. So this function looks like this. Nope, that's not right. Like this. Okay. And then there's a kind of a hole. There's a hole at 3. We don't know what it is exactly at 3. So here's what this function looks like, kind of piecewise. Less than 3, it follows the line y equals x. And to the right of 3, it follows the line y equals 0. So what is the limit as x approaches 3 from the left? Well, when x approaches 3 from the left, I can look at what's happening as it gets closer and closer to the left. And as it gets closer and closer to the left, it looks like it's approaching kind of this number right here, which would be 3. Numerically, I would plug in numbers slightly less than 3. So let's go over here. So again, when x is less than 3, our function is x. That was defined right here. F of x equals x when x is less than 3. So if I'm going to plug in numbers slightly less than 3, let's say, right here, let's say f of 2.99, well, that is 2.99. If I plugged in f of 2.999, I get 2.999 out. This is a very simple function. So I could say my limit as x approaches 3 from the left of f of x is absolutely 3. That would be my final answer. We got that numerically by plugging in smaller numbers. We also got there graphically because from the left side of this function, as I'm getting closer to 3, I get closer to 3. There you go.